Hey, good morning, pre-algebra class. Glad you tuned in today, and we're going to learn about slopes today. And also, I want you to just be aware that Monday will be a work day for you on the next assignment. So today, your big thing is to watch and take really, really good notes. So take your time, make sure you're taking good notes. You might want to take a little time and make some graph paper afterwards if you don't have access to a printer, because practicing these things and graphs and being able to see them in front of you might be very, very helpful to you. Or if you have a printer, it might be helpful for you to stop right now and go and at least print out the page that has the graphs drawn so that you can count right along with. So I'm just giving you that as a little heads up. Slope is really a way of measuring steepness. Now, you probably have encountered the word slope before, maybe, maybe not. This might be your introduction to it, so I'm going to treat it as if it's an introduction. So a slope is a degree of steepness. So in other words, the more steep a slope is, the bigger the number is, the further away from zero the number is. So you can imagine if you have a hill that's very, very steep and you can go down the hill. Going down the hill would be a negative going down, although it could be fun rolling down that big giant hill. But if it's very, very steep, there would be a high number, a high negative number, like maybe a -5 would be its steepness. And then as it gets more shallow, you might have a number like -1, where it's not quite as extreme, or -0.5 if it's like really, really kind of a gentle hill. Also, you can think about climbing up a hill, and up a hill would be a steep hill, would be a positive number. Like the extreme climbing, for somebody who's an extreme climber, would have a number that might be maybe an 8 or a 9 for a slope that's like very, very, very steep. But then as it gets to be a gentler one and it's just like walking a little bit uphill, then the steepness gets to go down and the slope gets to go down. So you might have like a 1 or even a 2/3 or a 1/5 for a slope. And then if you have something that's just flat across, that slope is going to be 0, because there's no challenge to that at all. That's just walking around. You're not going to have gravity helping you or hurting you as you're walking straight across a flat surface. So the steepness of that would be 0. And then you'd have like the ultimate extreme where you've got like a vertical straight up and down. Okay, if you tried to climb that thing, it would be impossible unless you were Spider-Man. But we're talking about with the real world, not having any pickaxes or anything. It would just be completely impossible to go straight up and down vertically. So that would be, actually, we would say there's no slope on that, or we would say, more correctly, we would say that it's an undefined slope. Okay, straight up and down will be undefined. You can't even really think about that. If you tried to climb up it, or if you tried to slide down it, you wouldn't be dealing with the slope at all. You would just be falling. So there would be no slope to that. That would be a undefined slope, we would call that. So of course, since we're in math, what we need to do is we need to put a number with that. So we're going to work on finding those numbers to go with slope. So if I just minimize this, this will be the easiest way. I have this graph, and I've got all of these lines on here. I've labeled them A, B, C, D, E, and F. So we're going to talk about the slope of each of these lines. Okay. A slope can be found by counting how far vertically divided by how far horizontally. In other words, we can consider that as our change in y over the change in x. So it's our vertical change as a fraction divided by our horizontal change. A lot of people will think about this, and this is very standard, as rise, how far up or down, over run. how far sideways. Rise over run, okay? Rise rhymes with wise, which makes you think of the y-axis this way. If you have the x-axis and the y's go this way. Vertically, it's the change in the y's over change in the x's. So what we're thinking about here, rise over run, y's over x's. Rise and y's rhyme with each other, and it is super important that you're thinking about the y's being over the x's. Don't reverse them. Okay, so y's over x's, rise over run. So when we're trying to figure out the slope of the line, we can do it by counting. So we're going to look at the slope of A. Okay, the slope of A is going to equal the change in the y, so I'm just going to count. If I'm going to go, I have to figure out how far vertically first. So it goes up 1. That's the top part of my fraction. I change in my y is up 1, and 1, 2, 3, 4 to the right. Up 1 over 4. So this is what we would call the slope of line A. Up 1 over 4. Okay, let's look at the slope of line B. Slope of B. So we're looking at slope of B. You can pick any 2 points on there. Now sometimes points will be bolded in, like these two, and you can count from one to the other. So I'm going to start here, and in order to get to here, we have to figure out how far up and over. Okay, so the rise is 1, 2. And our run, so 1, 2, rise. 1, 2, 3, 4, run. Now, just like in any fraction, anywhere you do it in math, you need to reduce this to lower terms. So this one, because 2 goes into the numerator and denominator, when you divide numerator and denominator by 2, we get 1/2. So this would be a slope of 1/2. These are both positive slopes. Going up to the right is a positive slope, so we need to get those ideas into your head as well. Because when you're looking at a graph, sometimes, and then you're trying to count it, sometimes people will get confused with their positives and negatives. But if you say, wait a minute, I know up and right is positive, that's going to help you at the end to check and make sure you've done your work right. Okay, so my rise over my run. Let's look at the slope of C. Okay, the slope of line C. Okay, well this one, okay, we've got a ways to go here. We're going to go from this point to this point. We go down 1, 2, 3, 4. And when we're going down 4 to get to that level, down 4, that's a negative. Okay, it's not, because we're thinking rise over run, but we're not going up, we're going down. And down is the opposite of up. Negative is the opposite of positive. So when you have one that's going down, you have a negative. And then your run, 1, 2, 3, 4, 5, 6. And that reduces to negative 2/3. Now I want to, before we go on to look at the others, even though we could very easily go on and do D right now, I want to backtrack really quickly on these. A slope of a line does give you the rise over the run, but you can use that slope to find other points on your line. So for example, if I have, here's my 1 point, it happens to be the ordered pair 1, 2, okay? But I've found that my slope is up 1 over 4. If I go up 1 over 1, 2, 3, 4, I find another point on the line. And that's super important to get into your heads also, is there are infinite points that follow that same pattern. I could still go up 1, 1, 2, 3, 4, and I'm still going to find a point on that line. Now, here's an interesting thing. You know how positive over positive gives you positive? So this is a positive slope. Negative over negative also gives you a positive. So if you want to, instead of going up 1 over 4, you could go down 1 and left 4. And once again, that's going to give you another point on the graph. So down 1, 1, 2, 3, 4 would give you another point that was on this line A, because up and right is the same as down and left, because negative over negative also makes positive. I'll let that sink in a little bit. This is kind of, I'm taking the lesson, I'm giving you a full lesson on slopes. What your job for your homework is going to be counting the slopes, but I want to make sure you understand all about them. So B, we found that for these 2 points that we have, up 2 over 4 is the same as 1/2, which is up 1 over 2. And look, you have another point on the line right there. You could go from any point and find another one by going up 1 over 2. Same with our negative 4/6 reduces to negative 2/3. So down 4 over 6 is the same as going down 2, right 3. And the slope number tells you how to find more and more and more points that are along that line. That will be very, very important for you as you go forward in algebra. Okay, it's going to keep with you for however long you're working on algebra. So we got to make sure that we're thinking about that. Okay, let's look at the slope of D. Slope of D, let's look from this point down to this point. And if for some reason points are not put on there, you can put your own points in as long as they're right in the corners so you can count easily. So I'm going to go down 1, 2, 3 and right 1, 2, 3 in order to find my next point. Down 3, right 3. And that reduces to a negative 1. So yes, you can get a negative answer. And yes, your denominator of your slope can disappear when you reduce your fraction. But let's think about this a minute. Any fraction, any number is a fraction. All you have to do is put it over 1 and you have the fraction that this goes with. So this negative 1 is really negative 1 over 1, which let's think about that. Down 1 over 1. There's another point. Down 1 over 1. There's another point. So this slope of negative 1 means it's going down and over. And look at these two. They're both negative slopes. We got negative for both of them because they're going down. It's like you're rolling down the hill this way. And these are like you're climbing up the hill. That leaves us to these two. These are different. These are easier thought about the way I just told you a minute ago. Okay? These are easier to think about if you don't do any counting at all. Okay, because if I'm looking at the slope of E, this is flat this way. And if you remember a minute ago, I said that that has a 0 slope. It does. It's a 0 slope. Think about this way. If you're counting how far up for your rise over your run, it doesn't go up at all. It's a 0. And then your run would be 1, 2, 3, 3 sideways, but 0 up, and 0 over anything is 0. And then we want to think about the slope of f. The slope of f, well, we can have a rise, 1, 2, 3, we're going down, or you might even say, well, I'm going from this point to this point. I have 1, 2, 3, up 3, but sideways is 0. And you should know by now that you can't have a 0 in the denominator of a fraction. It's undefined. Or you would say no slope. Undefined is the better mathematical term for that, so I want you to use undefined. Your book in the back of the book will say no slope, but a better mathematical term is undefined, and we're going to use that. Okay? Now, that looks like that. I would like us to look at this for a minute, and I want to just put another concept in your head. If this line is here, it has a slope of 1/4. But if I take that and I drag it and I move it somewhere else, it still has a slope of 1/4. The tilt of that line has not changed at all wherever I put it on the graph. It still has a slope of 1/4. This one had a slope of -2/3. But if I drag it somewhere else on the graph, okay, it still has that same pattern of down 2 over 3. It's just found in a different place, the whole line. Okay, so different lines can have the same slope even if they're at a different place on that coordinate plane. So I can even copy this one, and when I paste it and I drag it to a new place, okay, these lines that have the same slope, this is just a little quick addition. These lines that have the same slope will be parallel to each other. If you think about that word from your past somewhere, parallel lines will have the same slope, but they won't be in the same place in the coordinate plane. Let me look at this one. If I make a copy of that one real quick. Okay, this one. Oops, I just moved both of them all together. Didn't mean to do that. Here we go. Take just one. But this can move all over the place. It still has the same tilt to it. It's the same, but these two lines are parallel to each other. So that's just a little thing on there. I did not give you questions on that, but it's going to hit you in algebra, so I want you to have heard it. Okay, some things that you don't get tested on, because a lot of times I get asked the question, will it be on the test? But that's not the be-all, end-all question. The question is, will we have time to have it on the test? But yes, you're going to see it again. So you've got to make sure that you're thinking along those lines. So the other thing we need to consider is what happens when you don't have the points graphed, but you're giving a couple of points and they tell you to find the slope of the line that goes between those 2 points. And you don't have graph paper, but you don't need it for always doing that. We have a formula to calculate the rise over the run. So we are going to take a look at those type of things. So we have this, which is great for counting and it's great for learning so that you know what's happening with these. But we need to take this change in y over change in x and extend it to problems that look like this. So what I need to do is I need to introduce to you our slope formula. Okay, our slope formula being the change in y's over the change in x's. Okay, slope equals the change in y divided by the change in x. That's all well and good, but what we're going to do is we're going to do that as a formula, okay? If you have a change in numbers, it means that you can find their difference, which means subtract. So we're going to be subtracting the two y values. The way that this looks is we take the second one minus the first one over the second x value minus the first x value. And that will give you the change. Here is your formula. These numbers are called subscripts. This is your first introduction in this class, I believe, to subscripts. Notice that it's written down below a little bit. That's where the prefix sub comes from. So they're below the line, and they are not a number to multiply or divide or add or subtract from this y. They're simply labels. This 2 means it's the second point, and this 1 means it's the first point. This 2 means it's the second point, and this 1 means that it's the first point. So when you are doing this calculation to find the slope, you figure out, you pick what point you're going to have as being your first point and what is your second point. And each one of these has an x value and a y value. This is the first point, so 2 is x1 and 7 is y1. There's an x value and a y value. This is our second point, so this is x2 and y2. I would highly suggest always labeling your points, labeling your values, so when you use this formula, y2 minus y1 over x2 minus x1, you are very careful about where the numbers go in. These are easier, but we're going to do some that have negative numbers, so you need to make sure you have it organized. Follow your sign rules, and by doing this, it's going to make there be less opportunities for mistakes. So I've labeled them. It makes it very easy to see. 13 is y2 minus 7 y1 over 4 minus 2. And it does matter, okay? You can't just do, well, I want to take 13 minus 7 and then 2 minus 4. You have to, whichever ones are the ones have to go second, and whichever ones are the 2s have to go first. All right? We could, if we wanted to, we could have changed this up. We could have made these the 1s and these the 2s, and that would be fine. But then it would reverse both of them, okay? And if that last statement just confused you, ignore it. Always make this one the first one and this one the second one, and you're not going to have to make a decision. 13 minus 7 is 6. 4 minus 2 is 2. So our slope for those 2 points is 3 when we finally reduce it. We did not have to graph them. We did not have to count. We're using the formula. For now, I'm telling you, to make yourself work it out right, always label your points, x1, y1, x2, y2. And because I teach so many different algebra classes, I know that this comes down the road. And there are, in geometry, there are several formulas where your first step is to label your x1, y1, x2, y2. So it's super, super important to be able to label these. This is an essential. You have to be able to do this type of skill. So y2 minus y1 over x2 minus x1, 2 minus 10 over 14 minus 9 All right, so when we do this and we are trying to do 2 minus 10, you're taking a bigger number away from a smaller number. You're really getting negative 8 there. Okay? 2 minus 10 is the same as 2 plus negative 10. So you make sure that you're remembering your sign rules. 14 minus 9 gives you 5. Now this number does not reduce. It is improper, but when you are doing problems involving slope, it's better to leave it an improper fraction than to make it into a mixed number. I'll say it again. When you're finding slope, you're better leaving it as an improper fraction rather than a mixed number. So I want to go back here and I want to write down so that you've got it very clear that you know that the answer here is the slope equals 3. And right here, our slope equals negative 8/5. If you're picturing it in your mind, it means that the line will be going downward this way. It would be going down 8 over 5. This one would be positive. It would be going up, and it would be going up 3 over 1. There's a hidden 1 there, so just so you have that in your mind. Okay, let's look at some other ones. Our slope formula, y2 minus y1 over x2 minus x1. If you'll notice, I'm taking the time to rewrite it again every single time. That's partly why for this one I didn't do a reveal thing. I'm actually writing it out as I go so that you can get that it's super important to do that. Here's our first point, x1, y1. Here's our second point, x2, y2. Always label first. y2, 19, minus y1, 4, over x2, 7, minus negative 3. And if you put parentheses around the negative, it does help you to keep track of what's happening. Okay, 19 minus 4, we know is 15. 7 minus negative becomes a plus positive, which gives you 10. And then you want to reduce that fraction. Both are divisible by 5. So divided by 5 gives you 3. Divided by 5 gives you 2. So your slope equals 3/2. And you picture that's going up and to the right because it's a positive slope. That's what you're picturing in your mind. You wouldn't necessarily want to graph 7/19 to find that answer. Here we've got another one. Again, x1, oops, never put two x's together. That's important. I need to, there we go. I actually need to see this. Never ever put the x here, so we need to change it. I need to, here we go, there's my eraser. Two x's don't go together. You have an x and a y. So let's make sure that you're careful. That's a very common mistake that people make. So we had to see it. You need to make sure you're doing an x and a y in each one of the ordered pairs. I need to go back to my pencil. x1, y1. x2, y2. Using your formula, y2 minus y1 over x2 minus x1. What just happened there also is a good reason why you physically label them rather than just mentally labeling them, so you don't forget, so that you have something to look back on, so that you can look for any possible mistakes. So here I'm taking negative 14 minus negative 5. And we're taking 7 minus 1. Minus negative, as we know, turns into plus positive. Keep, change, as many of you are very accustomed to doing. Negative 14 plus 5 gives you negative 9, right? 7 minus 1 gives you 6. This can reduce because numerator and denominator are both divisible by 3. And this gives us our slope. Negative 3 halves. Okay, 3 halves and negative 3 halves are two different things. 3 halves, positive means up this way, negative means down this way. All right. I know that this is a lot, and I know that you've been listening to me for a while, but there are different things that I have planned to show you in each example, so stick with me. Oh no, she's got mixed numbers in here. How can we do this? This is going to be so hard. Nope, it's not. But we follow our same pattern and our same rules. y2 minus y1 over x2 minus x1. All right, we're just going to make a big old fraction bar, and we're going to make it two different problems like it really is. I'm going to take 5 minus 2 3/8, and I'm going to take 4 1/4 minus 3 1/4. Okay, so here's the thing. Let's focus on the denominator a little bit first, because here in the denominator, this isn't as hard as it looks, because it's 4 1/4 minus 3 1/4. There's just one difference there. So don't make it harder than it needs to be. Okay, 5 minus 2 3/8. Let's make improper fractions there. 5 is the same as 5 over 1 minus 2 times 8, 16, 19 eighths. But then what we need to do is we need to make common denominators. This denominator here, you're divided by 1, so that's going to just disappear very soon anyway. But this is really 40 eighths minus 19 eighths, because 8 times 5, 40 minus 19. Let's borrow. And you get 21 eighths. But that's divided by 1, but anything divided by 1 is just itself. So your answer is 21 eighths here. So even though it was a little challenging because fractions, the part of the fraction disappeared for you. So don't get freaked out just because you see fractions. Just start doing the problem and do one step at a time. That's what I try and tell people who look at a problem that's, as they get more and more difficult, is that if a problem looks difficult, you're not solving the whole problem all at once in your head. You're solving the problem, figuring out, wait, what's my first step? I'm going to do that. And then moving on. So let's look at what happens here. x1, y1, x2, y2. y2 minus y1 over x2 minus x1. 9 minus 9 over negative 5 minus 3. And then 9 minus 9 is 0. And negative 5 minus 3 is negative 8. But 0 divided by anything equals 0. A 0 in the numerator means that you have 0 as an answer. Okay? A 0 in the numerator means that you have a 0 as an answer. So that's super important for you to know. Okay? Let's look at a problem like this. Oh my gosh, Mrs. Dowdy, what did you do? You've got that horrible big long number, but it's, once again, don't get messed up by a big number. Uh-oh, what mistake did I make? It shouldn't be 1 and 2. It should be x1 and y1. Okay, x1 and y1. And x2 and y2. Don't worry that there's big numbers there. Okay, I'm doing this with the big numbers on purpose because if I can give you a harder problem and explain it to you when you have a number that's like 3 and 7, it's going to make it super easy for you. But let's remember our slope formula, y2 minus y1 over x2 minus x1. 27 minus 2 over 3,297 minus 3,297. So you're getting really 25 over 0. But the thing is that you can never divide by a 0. If you try to divide by a 0, remember, you're really trying to say what number times 0 equals 25. That's impossible. So this is an undefined slope. Or you could say no slope. Okay, that's the way your book puts it in the back of the book, but undefined slope because there's a 0 in the denominator. Sometimes people have a hard time remembering which one's the one that turns into a 0 and which is the one that turns into undefined. Okay, undefined has a 0 in the denominator. And I like to give just this little trick for people is that when there's a 0 in the denominator, it's like a wheel on the bottom of the fraction. It falls over, can't have that. Okay, so that's just one other little trick. If we're thinking rise over run for slope, you're going up 25, but sideways not at all. And that's the undefined, that's your vertical line. So let's think about it in all those terms. All right, now your job is going to be to work on your homework assignment tomorrow, not tomorrow, on Monday. You're going to be spending the whole time doing a really excellent job on assignment 79 on Monday. And there will be an answer form up for you. Okay, and that answer form is not there yet, so you need to wait for Monday. Do it on Monday. Make sure you have a good weekend. When you enter them, it's going to ask you to enter all of your even numbers, because I did give you a lot of evens and a lot of odds. The odds you need to be checking in the back of your book so you make sure that you're doing them right as you go along. The evens, you're going in. You're going to enter all those even answers, and then as soon as you're finished, the submission form will release to you, and you'll be able to see which ones you got right and if there are any that you got incorrect. And so when you do that, you're doing that for yourself to find out if there's anything that you need to work on and anything that you need to ask for help about. Okay, so super important that you go through and do that, and then if there are anything that you need to ask questions on, you need to make sure that you're asking me the questions so that I can help you out. We're heading for a quiz next Wednesday. Okay, so Monday you're working really hard on this assignment. Tuesday we're doing some review. Wednesday will be your quiz on the 3 sections that we've been working on, sections 4, 5, and 6. All right? Thank you so much, and God bless you.